Hi, this is Mrs. Jackson. This is Chapter 3, Section 3, Part 2. In this video, we're going to review the long division algorithm, and we're also going to make some observations about the relationship between the dividend, divisor, quotient, and remainder. All right, so let's quick review long division. We're going to be applying this technique to polynomials shortly. So we're going to take the dividend, which is 1,952, and we're going to put that underneath the long division symbol, and our divisor is 32. Okay, so the first thing we want to look at is to see if 19 can be divided by 32, which it cannot, it's too small. So we're going to move over one place value and look at the number 195 and look at how many times 32 can go into 195. I think of 32 and I think it's just under a third of 100, and this is just under 200, so the number I would think in my mind would be 6, and I'm going to put that 6 over to this place value here since we're going all the way dividing 195, and then we're going to multiply the 6 times the 32, and I'm going to put that right underneath the 195. So I have 12, I'm going to carry a 1, and I have 18 plus 1 would be 19. So now the main thing here is I'm going to be subtracting this number. I'm going to put it in parentheses here because we're going to be shortly doing this with polynomials, so it's important that we put the subtraction of the entire polynomial. If we look at the difference here, 195 minus 192, we get 3. And next we are going to bring down that last digit here, and we've got 32, and of course 32 is evenly divided by 32, so one time, and we're going to again multiply that 1 times the 32, and we get our 32 here, and we're going to subtract that, and you can see that we have no remainder. Our remainder is 0. Now, if we have a remainder of 0, then one thing we can think of is that quotient is a factor of the dividend. So if we have no remainder left, then it must be a factor of the dividend. I could likewise say that if we have a 0 remainder, that the divisor, so we might as well write that, the divisor is also a factor of the dividend. All right, let's take a look at an example where we do not have a remainder of 0. So in the next example, I have 983 being divided by 18. 18 cannot go into the number 9, so we're going to move over to the next place value of 98. I think of 98 as 100. I think of 18 as 20. 100 divided by 20 is 5, so I think that's a good number here. 5 times 8 is 40. 5 times 1 is 5. Add the 4 and we get 9. And I'm going to subtract 90 from 98, and I get 8 left. And now I'm going to bring down that 3 and divide 83 by 18. I think of 83 as 80 and 18 as 20. 80 divided by 20 is 4. 4 times 8 is 32. 4 times 1 is 4. Add the 3 and we get 72. And we're going to subtract that from 83. And I get 11 out. And 11 equals our remainder because we cannot divide 11 by 18. So we would conclude that the result of this division here, I'll put it here, the result of the division of 983 divided by 18 equals 54 is our quotient, plus our remainder is 11, and we would say our we would put that remainder over the divisor. So our quotient is 54 plus 11/18. Now when we add a fraction here to a whole number, we usually bring them together. So we would also write this as 54 and 11/18. All right, so let's observe here what happened in terms of the dividend, divisor, quotient, and remainder. So right here in our example, we have a dividend divided by the divisor, and the result of that is our quotient, 54, plus our remainder, 11, over the divisor. And if that is true, we can do a little algebraic manipulation here and multiply the entire thing here by the divisor. So let's get rid of that denominator. I'm going to multiply every term in here by the divisor. So if I multiply dividend over the divisor by the divisor, then the divisors are going to cancel, and I end up with the dividend left. Likewise, if I multiply the quotient by divisor, I'm going to end up with the divisor times the quotient. And if I multiply the remainder over the divisor by the divisors are going to cancel. So I'm just going to have the remainder left. So in our example above, our dividend was 983. We could say that 983 equals 18 times 54, our quotient, plus 11, our remainder. And that's important because when we start to apply these concepts to polynomials, basically what we're going to be doing is rewriting the dividend as its factors plus the remainder so that we can break that polynomial down and hopefully give us some clues as to how to graph that function. That's ultimately where we're going to be going in the near future. All right, so I hope this little review of long division helps. Thanks for listening.